Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture. This is the 7th part of the series of CSIR NET Physics 2021 paper solution. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, and also guys, share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. So question number first is, these are part B questions. So this question first is, today part B questions are completed. So tomorrow I'll start part C questions of 2021. Okay. Okay. So question is, very good question. The volume integral. Meanwhile, just let me check whether I'm audible or not. Then I'll proceed. Question is, yes, I'm audible, so I'll proceed further. Okay. So question is, the volume integral, the volume, the volume integral, the volume integral I equal to volume integration. Very good question, guys. A dot del cross A, or divergence of curl of A. No, A dot del cross A. Sorry, it is going, and d cube x. Okay, is over a region, over a over a region over a region bounded over a region V, bounded by bounded by the surface, bounded by a surface, bounded by a surface sigma. Okay, an infinite symbol, and an infinite symbol, infinite symbol, an infinite symbol area, an infinite symbol area an infinite symbol element element being element being n cap ds. Okay, where n cap is the outward unit normal, is the outward is the outward unit normal, outward unit normal. Okay, so this is the area element given, infinite symbol area element. Okay, and if it changes to if it changes if it changes to I plus delta I plus delta I when when vector when the vector when the vector A is changed, vector A is changed, vector A is changed, vector A is changed to A plus delta, the A plus gradient lambda, okay, then delta I can be expressed as delta I delta I can be expressed as delta I can be expressed as options are option A, this is triple integration, that is volume integration del dot gradient of A cross A P cube x. Option B is minus volume integral del square lambda d cube x. Option C is surface integration sigma del cross gradient of lambda gradient of lambda gradient of lambda cross A dot n ds n cap ds and option D is surface integration sigma gradient of lambda dot n cap ds. Okay, so this is the question. It's a good question, guys, and so I'll explain it. Okay, so question, I'll read it for you. The question is the volume integral we have given. Okay, volume integral is given this. Okay, I equal to volume integration A dot del cross A d cube x. Okay, uh, this is over a region V. Okay, that is over region V bounded by the surface sigma. Okay, an infinite simple area element being n cap ds. Okay, so there is an infinite simple area element being n cap ds, where n cap is the outward unit normal vector. Okay, so this is the n cap is the normal vector. Okay, that on this area vector s ds. Okay, this area ds. Okay, if it changes to, okay, if it changes to I plus delta I. Okay, this volume, this integral changes from I plus delta I when vector a changes to a plus delta lambda. When vector a changes to a plus delta lambda, the I changes to I plus delta I, right? Then we need to find out delta I. Delta I can be expressed as, these are the options given. Okay, so I'll solve it. Very good question, and we'll use vector properties to solve this. Okay. Okay. So Now since we have been given I equal to triple integration a dot curl of a, okay, d cube x. Okay, so this is what we have been given in the question, right? This one. Okay, so now what we can do is, so now in that case I plus delta I is going to be this one, because this becomes I plus delta I when a changes to this one, a changes to a plus this, a plus gradient of lambda, a plus gradient of lambda dot del cross a changes to a plus gradient of lambda d cube x, a plus gradient of lambda. Okay, this is given in the question, a plus gradient of lambda. So we can write like this. Okay, so from here we'll use, now we'll open it by property, using property. So this is going to be I plus delta I, that is going to be this one. So here we can say this one, right? And we can solve it further. So we can write this like triple integration. It's a conceptual question, right? Triple integration, you must know the properties. Okay, so this is going to be a plus gradient of lambda, a plus gradient of lambda. Okay, and then dot, we can solve this further, right? So this is going to be del cross a, del cross a, del cross a plus del cross gradient of lambda, and this is d cube x, right? Okay, so here guys we know this property, since curl of gradient, okay, curl of gradient, that is curl of gradient equal to 0. I have already explained this property in my mathematical physics class. In short, I have explained fog equal to 0. Okay, so fog equal to 0 means curl of gradient. So this is curl of gradient. Okay, so this value will be 0. So what is remaining now? So I plus, it means I plus delta I is going to be, I plus delta I is going to be this is triple integration, that is volume integration, uh, a dot del cross a dot, this is going to be a plus delta lambda, a plus gradient of lambda, my apology, gradient of lambda dot curl of a, and this is d cube x, because this part is 0. So this one. Now we'll solve it further. So this is going to be I plus delta I, that is going to be, this will solve it. So this is going to be volume integration a dot curl of a dot curl of a d cube x, a dot curl of a dot curl of a d cube x plus volume integration, mm, volume integration gradient of lambda, gradient of lambda dot del cross A d cube x. Okay, this one. So guys, here you can see this one. Gradient of this volume integration A dot del cross A d cube x is I. This one. A dot del cross A d cube, right? So we can write I plus delta I, that is going to be I plus volume integration gradient of lambda dot gradient of lambda in col of A d cube x, or gradient of lambda dot col of A, or del cross A. Okay, this one. So this I will get cancelled. I will get cancelled. So delta I value is going to be volume integration the gradient of lambda dot del cross A d cube x. Okay, so this one d cube x. So here guys, we should know one more thing. Okay, this I'm going to explain this one. So now we'll solve this further. So here guys, there's a formula which you need to note down. Okay, this one. Gradient of it's del dot A cross B. Del dot A cross B. This formula you need to note down, guys. Okay, del dot A cross B is going to be B into del cross A. Okay, minus A into del cross B. This is important formula, guys. You need to note down. So cog I have already told you, and this you need to note down. Okay, so del this is going to be del dot A cross B. Okay, del dot A cross B. Del dot A cross B is going to be will you this the last one first. Okay, B, this is B dot, there will be dot, right? B dot B dot. Okay, so B dot del cross A minus A dot del cross B. So this is last one dot del cross A minus first one dot del cross B. So del dot A cross B equal to B del cross A, B dot del cross A minus A dot del cross B. So this formula you need to note down. Okay, so now uh, so here so in this case what we are going to do here, you can say this one, right? So we can do like this. Here A is, in this case if you talk about this, A is, or we can directly write, no need to write this, or we can write this one, del dot A cross delta lambda, A dot gradient of lambda. We can do like this, because here we can write like this, A is A and B is gradient of lambda, we can write. Okay, so we can do like this. So del dot A cross gradient of A. Okay, del dot A cross gradient of A. So if you open it by this formula, okay, so this is going to be we write this del dot A cross gradient of lambda, because this is vector, right? If you open this, this is going to be uh, gradient of lambda dot curl of A, right, minus A dot curl of gradient of lambda, right? So again, this curl of gradient of lambda, right? Gradient of lambda, that is C cog, that is cog equal to 0, right? Curl of gradient. This is curl of gradient, right? Curl of gradient means cog, that is 0. So this value is going to be del dot A cross del lambda. So del dot A cross gradient of lambda is going to be gradient of lambda dot del cross A. Okay, gradient of lambda dot del cross A. So you can see here this value is equal to this value. Okay, so this gradient of lambda dot del cross A, this value is del cross A, this value is equal to uh, uh, this one, this divergence of A cross gradient of lambda, right? So here we have this value, gradient of lambda dot del cross A, right? This value, we can write this value is equal to this value, right? So we can write triple integration that delta I equal to delta I is going to be triple integration volume B. This is the, so in place of this one, gradient of lambda dot del cross A, gradient of lambda dot del cross A, we can put this value, right? So this is going to be del dot divergence of curl of divergence dot or grade the delta del dot A cross gradient of lambda dq x, right? So this is the delta I value, delta I. Okay. Now we have this one, delta I equal to uh, volume integration del dot A cross uh, gradient of lambda, right? Gradient of lambda. Okay. Gradient of lambda. So gradient of lambda. So this value is going to be, now we have this divergence of this. This is divergence. We can use divergence theorem. Okay, here we can use that because we have del dot divergence of A cross delta, right? Divergence of A cross delta, and this is going to be d cube x, right? So we can use divergence theorem. We know the divergence theorem is used for converting volume integral into surface integral and surface integral into volume integral. So by divergence theorem, we know by using divergence theorem, so this value integration, triple integration, divergence of A cross del lambda, that gradient of lambda d cube x, this is going to, we can convert it into surface integration. So this is surface integration, that is sigma, because sigma is given, right, as a surface integration sigma, and that is going to be because we are using this is divergence theorem, and we are divergence of this, right? This is a vector, okay? This complete is vector. So divergence of this is going to be in surface integration. This is going to be this using divergence theorem. This is going to be this one, a cross gradient of lambda dot n cap ds. This is because n cap ds is the area element, okay? Area element vector. So delta I value is going to be surface integration sigma, surface integration sigma. This is a cross gradient of lambda dot n cap ds, right? This is the one. Or we can change this position, right? Because we need this answer, right? So this is going to be minus surface integration sigma, because you need to know, guys, the divergence theorem is used for converting it into surface integral. By divergence theorem, we can convert volume integral into surface and surface into volume. Okay, so this is going to be this one. That divergence dot this is going to be this and not this. Okay, so this is going to be this one, and here what we can do is we can change this sign, right? So this is going to be this term. So there we can write gradient of lambda cross a. So if it's a cross product, right? So there would be minus, okay, because we are changing the position dot n ds, and this is the answer, right? So which option is matching? Option C is matching. So this one, option C is matching, guys. You can see minus surface integration gradient of lambda minus the gradient of lambda cross a, gradient of lambda cross a and ds, right? So this is the one. So minus surface integration sigma gradient of lambda cross a dot n ds. This is the answer. So very good question, guys. Conceptual questions. You need to know it. So there are two things you need to know. That is, first is fog. Okay, fog means curl of gradient. Gradient is 0. Okay, and the second point you need to note down, that is important one, that is del dot a cross b. This formula is going to be very important. Del dot a cross b is b into b dot curl of a minus a dot curl of b. Using these two formula, you can solve this question, guys. I hope, guys, you have understood it. Okay, very good question. Next question I'm going to solve. Next question. This is also a good question, guys. Just give me 1 second. Okay, I'm just checking something. Okay, so there is one question. Okay, I'm going to solve it. So we have been given figure, guys. Okay, it's a good question. Question 2. The figure below, the figure below, the figure below, the figure below depict figure below depict three different three different wave functions The figure below depicts three different wave functions of particle, wave function of a particle, wave function of a particle confined to confined to a one dimensional box, confined to a one dimensional box, that is -1 greater equal to x 1, right? So which is between -1 to +1. Okay, this is what given, and this figure is given, guys. Okay, I'll make it. Okay, this figure is like this. Okay, this is the figure, and this is -1. This is 0.5, -0.5. This is 0, and this is 0.5, and this is 1. Okay. Similarly, this is 0. This is 0. This is 0.5, and this is 1, and this is -0.5. And here, this is the figure. Okay, so this is the figure. This is -1. This is 1. This is x. This is 0.5. This is 0.5. This is -0.5. Okay. Similarly, this is 0. This is 0.5. 0.5. Sorry, 0.275. Okay. This is scale given. Okay. So this is -0.5. -2.2 0.25 and 0. Similarly, 0.25, 0.5, 0.75 and 1. Okay, 1. Similarly here, this is the figure given. Okay, so here you can see this one goes down, this. Okay, there are number of bounces. Okay, and this is like this, and this. This is the graph for it. Okay, and this is -1 and +1. This is +1. Okay, so this is +1 between, and this is -1. Okay, so this is the graph. This is the graph, guys. Okay, so this is the graph given. Right? There are different peaks. Okay, there are different peaks. Okay. Okay, so now the wave function, the wave function, the wave function, the wave functions that corresponds, that corresponds that corresponds to the maximum to the maximum to the maximum expectation value. The wave functions the wave function that corresponds to maximum expectation value, that is mod of x. Okay, that is absolute value of mean position. Okay, absolute value of mean position, absolute value of mean position. Okay, and expectation value of x square. Okay, expectation value of x square respectively are. Option A, B and C, option B, B and A, option C, C and B, and option D, A and B. Okay, this is given. So here, this is graph A, this is graph B, and graph C. Okay, so this is the question, guys. It's a good question, guys. Okay, conceptual question. So question is, the figure below depict three different wave functions of a particle confined in one-dimensional box where x is between -1 to +1. Okay, my apology, guys. Okay, so yeah, so this is the wave function of particle which is in one-dimensional box. Okay, and the value of x is between -1 to 1. Okay, so these are three wave functions given of particle, right? Now what we have to find out, the wave functions that corresponds to the maximum expectation value. Okay, the wave function that so we need to find the wave function. We need to select the wave function that corresponds to maximum expectation value, that is mod of expectation value of x. Okay, and the expectation value of x square respectively are. Okay, so which so we have to find the wave functions that corresponds to. So we have to select we have to select the wave function that corresponds to maximum expectation value of mod of x and x square, that we need to find out. Okay, okay, so I'll solve it. Okay, guys, so here this problem we are going to will solve by property. Okay, so we'll solve this problem by using property. Okay, so using property. Okay, so first property is this one, guys. For a box of length n, okay, I'm checking camera as well, guys. Okay, sometimes it gets stuck, that's why. So for a box of length, I'm solving by property. Okay, using property, guys. Okay, for box of length, minus a, x is between minus a to d, x is between minus a to d. Okay, for a box of length x minus a and x d. Okay, when x is between minus a to d, this property is, guys. Okay, for this, guys, you need to know that value, expectation value. Okay, for a box of length minus a when x is between minus a to d, okay, this is always going to be 0. A into a, this is a into a, okay. So for a box of length minus a to a, okay, expectation value is always 0. Okay. Expectation value is always 0. Is always is always 0. Okay. This unit also for box of length, this expectation value will always 0. So this is the property, guys, we know. Okay. Second property is for a box of this, for a box of length, that property I'm using. Okay. Box of length when expected that value of x is between a to a, that mod of expectation value of x is always non-zero. Is always non-zero. Is always non-zero. Okay. And the wave function, and third is, these are property I'm writing. Okay. The wave function, the wave function, the wave function is of the form, is of the form. We have given the wave function. Okay. So for this, because particle in 1D box, right? And the wave function is of the form this, guys. So wave function is of the form psi x equal to, wave function is of the form psi x equal to a square minus x square. Okay. So the wave form is in this form, guys. Now we will normalize it, guys. Okay. For normalizing the wave function, so normalized wave function is going to be, this is the wave function, guys. Wave function for this question, wave function is in this form. Okay. So from here, the normalized wave function is going to be the normalized. If you normalize it, right? Normalized wave function. Normalized wave function is going to be, for this normalized wave function is going to be root 15 upon 16 e to the power 5 into a square minus x square. This is the normalized wave function. Okay. And so now expectation value is going to be that expectation value of x square is going to be, for this, if you find out, so this is going to be 15 upon, you can find it, 15 upon 16 a to the power 5 integration minus a to a x square, a square minus x square dx, and this value is going to be 16 a to the power 7 upon 105. Okay. We can find it like this. Okay. So thus we can say, thus at a equal to plus minus 1, a equal to plus minus 1, a equal to plus minus 1, this is for it, right? A equal to plus minus 1, the curve takes, a equal to plus minus 1, curve would take curve curve would take maximum and minimum values. Okay. Max and minimum values. Max and minimum values. Okay. So max and minimum value, and for curve, okay, so for For mod of expectation value of x, the curve is given. The curve given, the curve for this, for mod of expectation value of x. Okay, the curve given, the curve given, the curve given in the option, curve given in the option, in the option, for this value, the curve given in the option, curve given in the option B is non-zero. Okay, for this value, for mod of expectation value of x, the curve given in the option B is non-zero. Option B, the curve in option B will be non-zero. Okay. Okay. Next is so, and for this x square, for expression x square, the curve takes maximum and minimum value at x equal to plus minus 1, right? So the option C will be correct. Okay, for this, for this, for this curve takes, the curve takes max and minimum values, max and minimum value, minimum value at x equal to plus minus 1, means curve shown in the options. Okay, so for this, the curve takes maximum and minimum value at x equal to plus minus 1. Okay, in the curve, in the curve shown in the option C, shown in the option C. Okay, okay, so it means, so in the curve, for this curve, the expectation, the mod of expectation value of x is going to be non-zero, and for this curve, there are it takes maximum and minimum value, right? There are maximum, so maximum number of minimum and maximum. Okay, so for expectation value of x square, this curve is correct. This curve, this will be the curve. Okay, so B and C are correct. So which option is matching, guys? A, B and C. Okay, so this is the answer, guys. I hope, guys, you have understood it. Okay, so guys, today I'm going to stop here, and your B part questions are completed. So from next class onward, from tomorrow, I will start C, the questions from questions from part C. Okay. Okay, guys, and also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, and also, guys, share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, guys. So, okay, guys. So, thank you so much. Bye now.